Everybody's here. This is great. So I will just give a very brief, I'm not a Nextflow developer. You'll recognize all the people helping with Nextflow with this tag we have here, but the master of Nextflow has no tag because it's so important. It does not need to be tagged. It's Paulo here. I'll introduce here in a few minutes. I'm not a developer of Nextflow. I'm a user. And as a PI, I asked Paulo to develop something like Nextflow because we needed it for our research. And I'll just give you a very brief 5 minutes overview of where I think Nextflow fits in our research, which I hope will be inspirational for some of you. But I know that many people are coming here with different ideas of how to use Nextflow, and then all these ideas are very, very welcome. So my lab is historically dedicated to multiple comparison, and I think there are two biologies. There is a biology where you describe, and because description is never enough, at some point you realize you have to compare all the things you have described, okay? And these are really the two legs of biology: observation and comparison of things you have described. And comparing used to be Darwin taking two monkeys, two birds or whatever, and trying to tell whether they were similar enough to infer a common origin. But comparison has now become excruciatingly complicated in biology because you have zillions of data sets, and the throughput of omics is so huge now that accurate computational comparison has become the bottleneck of biology. And one of the things that strikes me when I look at currently available data is that the things we have to compare are increasing by the day. We are not just talking about comparing sequences, we are also talking about comparing structures, and we even have genomic structures now with the high-seq data. We have, of course, the genomic sequences with epigenetics data being gathered by the truckload. We have, and that's relatively new, we have all these omics phenotypes, the transcriptomics, the proteomics, the metabolomics, and the newest kid on the block, which has not yet made a full entry, is big data. We have huge amounts of longitudinal data that is being gathered by all these devices we have, all these iPhones, all these tracking devices we have. That data will have to make its way into our pipelines at some point. And we must have the tools that allow us to do this analysis properly. And interestingly, in my opinion, this defines a new biology that I call precision biology as a correlate to precision medicine. It will be the supporting biology for precision medicine. And this new biology needs what? It needs ultra-powered data. And the biologists have been doing the job for us. They have put together all these amazing machines that have made totally redundant the bioinformatics of my youth. The predictive bioinformatics is gone. We won't have to predict anything in bioinformatics. We just measure. The tools are so powerful that everything, all the structures we were trying to predict, all the RNA we were trying to predict, it's finished. You measure it, but you have to integrate it. And fortunately for people like me, the algorithms doing the integration are the same as the ones that were doing the prediction. I still have a job. But these are not predictions, these are real models, these are experimental models. So it's very exciting. So we need efficient and accurate algorithm, and that's where my lab stands, and I think quite a few of you here. We need reproducibility, and that's where Nextflow stands. That's the IT layer of computer science. And this IT layer, that used to be not so exciting, it was a little bit boring, and you would have a fight with your sysadmin and then discuss something else, has become totally central to our work these days. How much memory, how much CPU, how much disk, how much do we need? These are central questions to any lab, and probably to the lab all of you are coming from these days. And of course you need the right statistics, and that's a problem. We're just scratching the surface, but I believe that for a while the true statistics we need in biology will not be tractable. They will be based on simulation, which will require a lot of computation. And the amount of data is staggering. This is a slide I hope you're not showing in Paulo because I stole it from Paulo, but these are all the terabytes and petabytes that are currently being produced by all this genomic data. And this is already months old. Everything has probably doubled since this stuff was. So the problem here is reproducible computation. I'm sure you're all aware that every second week you have in Nature a paper about the issue of computation not being reproducible. And it's so complicated that we even realize that the wording is complicated. Reproducibility is a catch-all word, but in reality we talk about repeatability, redoing exactly the same computation with exactly the same data. We talk about reproducibility, experimental reproducibility, gathering roughly the same result from the same condition, and all these type of things. It's a complicated problem. In Nextflow, and you can see this, the number of papers describing or related to these things is increasing exponentially. So Nextflow made it in Nature Biotech, and the reason it made it in Nature Biotech is not only because it's a very good workflow, because there are also good workflow. We like to think ours is the best, and I'm sure all of you are convinced this is the case, or will be convinced on Friday. But the reason we made it in Nature Biotech is interesting. We made it in Nature Biotech because we came across a very interesting, a very interesting observation. So Nextflow is a great tool, and we put it together, Paolo put it together to help us very, very rapidly bundling existing pipelines. And then you will hear a lot of technical stuff about this. And these guys really blew our mind because just after Paolo dumped Nextflow on Gitter, the Sanger started using it and found this was exactly the tool they needed. And they bundled together one of the most complex pipelines we have. You know, it's a companion pipeline. It's a pipeline they use for eukaryotic predictions. It's amazingly complex. And so when running this pipeline, we found out that giving the same genome, the same version of the pipeline, you will get slightly different gene prediction on different operating systems, okay? Which makes no sense to anybody. This should be rock solid reproducible, and it turned out not to be rock solid reproducible. But if you bundle Nextflow with a container technology like Docker, you get exactly the same result on all your platforms. So these are tiny variations. From a biological point of view, they make no difference. You get roughly the same interpretation. But from a traceability point of view, from a troubleshooting point of view, it's a disaster. Because now you have a problem, you try to reproduce the result you had 6 months ago to get exactly the same output, and to fix your problem, you cannot. And you're doomed. And combination of containerized technology with Nextflow solved it. We had exactly the same issue with Callisto, where we found that if you give exactly the same data set to Callisto on a Mac, Linux, Unix, and on Amazon Linux, you get slightly different readouts, which is, again, a major issue, but you get exactly the same when you use these things containerized. I will not tell you which one is right or wrong. I don't know, and they're probably equal. You know, these are noises, but they are very detrimental from a reproducibility point of view. And as I like to say, you know, it's not fun if you only have bad news for a few people. It's nice if you have bad news for everybody. And in this paper, we had bad news for everybody because the same issue arises when you make phylogenetic computation. Yes. So what shall we do? The answer is very simple. Docker, numerical stability, that make it possible to have analytic replication. Then all this very nice integration you will hear about, integration with GitHub, Bitbucket, all of these things that really are a thing of the future. And I'm very, very proud to say that Nextflow has been amazingly successful even before its publication. You know, we have all these very, very high-power users that are porting their pipelines into Nextflow, and we're thrilled with this. So, last slide. I really want to thank the members of the team. I want to thank Paolo, who is really the mastermind of Nextflow. He has organized this workshop single-handed, and well, with the help of Damiana, of course. And the thing that I really admire on this project is that Paolo has managed to federate a community of users through social networks and through all this combination of tools that have made it the vibrant project it has become. And this is only a start, obviously. And I also want to thank the students who have been involved in this, especially Evan and Maria, who have been supporting the project, and of course Damiana, who has helped us organizing the workshop. I really welcome all of you here, and I'm extremely excited about what's going to come out of these 2 days. Thank you.